Hi guys, welcome back to AP Environmental Science. In today's video, we're going to be covering topic 2.9, which is Earth's geography and climate, as well as topic 2.10, which is El Nino and La Nina. So make sure you're filling in the corresponding pages in your notes, and let's get started. So in last video, we discussed why does the Earth have seasons and like solar insolation, which is unequal heating of the Earth due to the Earth being tilted on an axis. Today, we're going to talk about the Earth's climate and how the climate is influenced by several things, including geography. So, climate is the average temperature, which is or how hot and cold different parts of the world are. So, the average temperature in an area, as well as the average precipitation, which is how much it rains in any given time. Climate is largely determined by solar insolation, which is the amount of sunlight that is being brought to the Earth. And remember, solar insolation depends on the tilt of the Earth, with the equator and areas near the equator receiving more solar insolation than areas towards the poles. So areas near the equator tend to be warmer because they're getting directly hit with the sunlight, whereas areas near the poles are less warm. They typically tend to be very cold because they receive less sunlight. Higher latitudes receive less solar insolation, so they're cooler and drier, whereas the equator receives the most intense solar insolation. They have higher temperature. This causes the air to rise because heat is less dense, so it rises, and that means it rains more in these areas. Geography also plays an important role. Mountains disrupt wind and produce the rain shadow effect, which we'll talk about in a few slides, and oceans moderate temperature and add moisture to the air. You guys might be a little bit familiar with this because we do live closer to the beach, but areas along the shore tend to have a little bit more milder climates. It snows a lot less during the winter months near the shore because the ocean holds on to a lot of heat in early winter. So if you've ever been to the beach in early summer, the water is really cold. But if you go to the beach in September or even October, the water is really warm because it heated up all summer. And the ocean holds on to that heat, making it a little bit warmer near the shore, making it snow less in the wintertime. The further you are inland, the further away from the beach, you actually have more snow and it tends to be colder. So this is the rain shadow effect. This is when you have mountains preventing clouds and precipitation from moving past to the other side. So as we know, warm, moist air rises because heat is less dense, so it rises. So warm, moist air from the ocean hits the windward side of the mountain. Windward just means the direction that the wind is hitting. We know that the warm air rises. Once it gets up here, it cools and the air is going to sink. But before it does that, it's going to rain. So as we can see on the side of the mountain, it is warmer and has more precipitation. So we have lush green vegetation here. As it rains and the air moves down because it's sinking, it's cool, dry air on the other side of the mountain, and it's going to be arid on this side. And this is what causes desert conditions. This is a part of the reason why certain parts of the Middle East are so dry and arid, but places in India are very lush and wet because of the mountains that are in India. So the rain shadow effect is essentially when you have a mountain blocking any clouds from being able to pass them because it rains on the windward side of the mountain, pushing the dry, cool air to the leeward side of the mountain. This you guys can fill in your notes. Explain why it is hotter at the equator than at the poles. So take a second to fill this in now and check your answer. So that was 2.9, very quick. Let's do 2.10, which is El Nino and La Nina. So, as we just discussed, the oceans carry massive amounts of heat. This should be a review from topic 2.8. Remember albedo, areas or places with low albedo absorb a lot of the sunlight. They reflect low amounts of sunlight. So areas with low albedo are going to absorb more sunlight, meaning that they hold onto and absorb more heat. It tends to be darker colored objects. The ocean is very dark, so it's going to have a low albedo and absorb a lot of solar insolation, a lot of sunlight, and thus be very warm. So the oceans carry massive amounts of heat and affect the climate of continents. The ocean currents are driven by unequal heating, gravity, wind, salinity, which is how salty, as well as the continent location. So the same concept we're talking about with wind in class, where warm air rises because it's less dense and cold air sinks because it's more dense. The same concepts apply to water, as we saw in the Coriolis effect lab. So warm water is going to rise and cold water is going to sink. And this is going to drive currents all around the world. So as we just discussed, the sun is directly hitting the earth near the equator, making not just the land, the continents warm, but also the areas of the ocean warm during all times of the year, specifically near the equator. So as the sun warms the equator, tropical water expands to be taller than the middle latitudes. This height allows gravity to let the water flow away from the equator. Winds deflected by the Coriolis effect also drive surface currents from the west to the east. Currents rotate clockwise in the northern hemisphere and counterclockwise in the southern hemisphere in gyres. As the surface currents move away, some of the water near the bottom moves upwards in a process called upwelling. So the same thing, you have cold water sinking, but as it's mixing with the warm water, the colder water towards the bottom is going to start rising up because it's becoming warm as it mixes with the warm water near the equator. And this brings nutrient-rich deep water up to the surface, providing photosynthetic organisms a bunch of nutrients so they can grow. So when the surface water and deep water mix, this causes thermohaline circulation, moving heat and nutrients around the globe. So this is a really basic, brief overview of thermohaline circulation. Water is going to flow here from the Gulf of Mexico away from the equator to the North Atlantic, where it's going to freeze and evaporate. The remaining water is now saltier and denser, so it sinks to the bottom of the ocean. So again, it starts out here, it's warmed by the sun hitting it because it's near the equator. It's going to float and flow all the way up here away from the equator. And it's going to get cold up here because we're near the poles. Less solar insolation, it's going to be colder. The water gets cold, so it sinks to the bottom and it starts being pulled back towards the equator all the way down here to the South Pole, where we have a very deep cold current. The cold water travels along the ocean floor, connecting the world's oceans. Eventually, it makes its way back up here, and it rises to the surface as it becomes warm, and it circulates all around the globe. Okay, so shallow warm water currents are near the surface. Deep cold water currents are near the bottom of the ocean. Now we have the concepts of El Nino and La Nina. So ocean currents can shift when there is a shift in prevailing winds and currents influencing global weather. We know that in the South Pacific, trade winds and the Coriolis effect cause water to flow from east to west because of the deflection of the wind due to the Earth spinning from west to east. So every 3 to 7 years, the tropical currents move in the opposite direction. This is called the El Nino Southern Oscillation. So this happens every 3 to 7 years, and it shifts between an El Nino, a La Nina, and neutral. So oscillations or shifts regularly from an El Nino year, which tend to be warmer and rainier, to a La Nina year, which are cooler and drier conditions along the coast of South America. We are currently in an El Nino year. So here's a normal year. We know from our lab that trade winds blow water east to west near the equator. Those are the trade winds. We know that cold water upwelled as it becomes warm and rises, causes all the nutrients from the bottom to be brought up to the surface, allowing photosynthetic organisms to have a huge bloom. We know that photosynthetic organisms are at the bottom of the food chain, meaning that any primary consumers that are available to eat them will also have a boom in population. This leads to really good fisheries and a really big surplus of food, as well as money from the buying and selling of the fish. The warm currents bring heat and precipitation to Australia and Southeast Asia, and there's a high pressure system in the East Pacific near South America, and a low pressure system in the West Pacific in Australia. So, normal year is good for fisheries because we do still have the upwelling of the nutrients in the Pacific Ocean. However, during an El Nino year, the trade winds weaken and they reversed. So now they're going from west to east. So this then moves the warmer water towards South America. So the current brings heat and precipitation to the Americas, whereas the Australia coast and the Southeast Asia area is now going to be cooler. Because this water is so warm over here, it's not going to mix with the colder water underneath. So we're actually going to have suppressed upwelling off of the coast of South America. So because we're not having any upwelling, the nutrients from the bottom are not being brought up, meaning that there's no nutrients allowing the phytoplankton to bloom and grow. So when you have a decrease in your primary producers, we should know from bio that you're also going to have a decrease in primary consumers as well, because they have nothing to eat and the food chain is going to have a collapse. Now, in a La Nina year, it's the exact opposite. It's basically a better normal year. So stronger winds, stronger trade winds than normal. They're really blowing strongly from east to west. This is going to increase the upwelling off of the South American coast. So we have extra good fisheries. So this is really great upwelling, a ton of nutrients being brought up to the surface from the bottom, and we're going to have a warmer and rainier than normal conditions in Australia and Southeast Asia. So we're currently in an El Nino year, meaning that our trade winds are blowing from west to east in the opposite direction, and we are not going to have as much upwelling, resulting in low productive fisheries. And here's just a review of El Nino and La Nina. And here is your AP skill practice questions. Go ahead and fill these in your note packet. If you have any questions, please let me know. We are done with the video notes for today. I will be here after school Tuesday, Wednesday, and Thursday for the extended school day program. On Thursday, we are doing a review session for our first test. As a reminder, White Day students, you have your test on Tuesday, October 24th. And my Blue Day students, you have your test on Wednesday, October 25th. I will be holding a review session on Thursday, the 19th, as well as Monday, October 23rd. I hope you guys all have a great day. I'll see you guys in class. Bye.